Alright, hi everybody. Today we're going to talk about Objective 1.8, which is about linear modeling. Alright, sorry about that. Alright, so when we use equations to model real-world phenomena, we often look at linear models first because they are the easiest to use and understand. We can now use our skills from the last few lessons to model real-world linear phenomena. Alright, so one thing, don't ever forget these two facts about linear models, okay? One thing is that all linear models in the form y equals mx plus b have two parameters, the slope and the y-intercept. So that's review from last year. M is our slope and b is our y-intercept, okay? The slope m always tells us how fast the output is changing relative to the input. So that's just a really fancy way of saying whatever is our rate, okay? And you'll see what that means in a minute, okay? Note, remember that slope, another word for slope, is average rate of change, right? So today, we're going to be dealing with some rates, and we'll review what that means in a minute, okay? But we're going to be dealing with rates, and that's going to be our slope in our equations that we're dealing with, okay? So the y-intercept, b, always tells us how much we start with, or the output starting value. So this is our initial value. Our y-intercept is our initial value, always. All right? So let's just dive right in. Let's take a look at an example. So Janine has $450 in her savings account at the beginning of the year. She places money in the account at the rate of $5 per week. We want to model the amount of money she has in savings, S, as a function of the number of weeks she has been saving, W. Fill out the table below for some of the number of weeks. Show the calculations that result in your answer. Okay, so if she, after 0 weeks, meaning she hasn't started saving yet, okay, she's only going to have $450 that she started with, plus nothing new. So she's only going to have $450 in her account to start. That's the initial value, okay? At the beginning, she has $450 at the beginning. $450 beginning. So that's our initial value. That's going to be important in a minute, okay? Now, after 1 week, she has the initial $450 plus, well, she's also saving $5 per week. So she has another $5. So she has $455. So she has the 400 she started with plus another 5 that she saved in that first week. Okay, after 5 weeks, she has the 450 that she started with, plus she's saving $5 a week for 5 weeks. So at the end of 5 weeks, she has $475. Okay, after 10 weeks, she has the original 450 again, plus $5 a week for 10 weeks. So she has $500 in her account after 10 weeks. Okay, so now letter B says to use information in the givens or in the table to write an equation for the saving S as a linear function of the weeks she has been saving W. All right, so I highlighted these in yellow and this in pink or purple because $450 is our initial amount. Okay, $5 per week is our rate. So I'm going to write that down again just to reinforce that. So 450 is our initial amount. Okay, we said up top that our initial amount is always our y-intercept b. Okay, our rate is $5 per week. That's our rate. Okay, or our m. So our equation is going to be S. Okay, that's the amount of savings that she has from our problem. S equals 5 times W plus 450. So our rate is $5 a week. That's our slope. And our initial value is 450, so that's our y-intercept. So this is our final answer. This is the equation that we have to model how much money she has in her account after a certain number of weeks. Okay? Letter C. Why would it not make any sense to evaluate S of 6.5? In other words, what type of numbers belong in the domain of this linear function? So 6.5, right? Our x, or our inputs, are number of weeks, okay? So if our input are number of weeks and she's making $5 a week, right? It wouldn't make sense to calculate how much she makes after a half a week, okay? So try to write something like that. It wouldn't make any sense to calculate how much she makes in half a week because she makes $5 per week, okay? All right, let's take a look at 2. Amanda is walking away from a light pole at a rate of 4 feet per second. If she starts, initial, right? If she starts at a distance of 6 feet from the light pole, which of the following gives her distance d from the light pole after walking for t seconds? So we have a rate, which is 4 feet per second. That's our rate. And we have an initial. Okay? So remember, our formula is always going to be y equals mx plus b, where m is our rate and b is our initial. Okay? So our rate is 4. So our equation is going to be 4x plus our initial was 6. Okay? Now we don't want y and x. We want d and t. Okay? So distance is her y, and we want x to be our time or our t, so our answer is choice 1. Okay? Now letter B, use your equation from part A to determine how far Amanda will be from the pole after 15 seconds. So 15 seconds is our t. So we need to evaluate what is the distance after 15 seconds. So if our t is 15, all we're going to do is plug in 15 for t. And we're going to get how far she is from the pole after 15 seconds. Alright? So 4 times 15 gives us 60. And 60 plus 6 gives us 66 feet away. So that means that after 15 minutes, she's 66 feet away from the light pole. I'm sorry, after 15 seconds, she's 66 feet away from the light post. Okay, so that's 1.8. Have a wonderful day, guys. Please feel free, as always, to reach out if you have any questions.